In this lecture, we will learn architecture models. Software architecture involves the high-level structure of software system abstraction. By using decomposition and composition with architectural style and quality attributes, a software architecture design must conform to the major functionality and performance requirements of the system, as well as satisfy the non-functional requirements such as reliability, scalability, portability, and availability. A software architecture must describe its groups of components, their connections, interaction among them, and deployment configuration of all components. A software architecture can be defined in many ways. UML stands for Unified Modeling Language. It is pictorial language used to make software blueprints. UML was created by Object Management Group (OMG). The UML version 1 specification draft was proposed to the OMG in January 1997. It serves as a standard for software requirement analysis and design documents were the basis for developing a software. UML can be described as a general-purpose visual modeling language to visualize, specify, construct, and document a software system. Although UML is generally used to model software system, it is not limited within this boundary. It is also used to model non-software systems, such as process flows in a manufacturing unit. The elements are like components which can be associated in different ways to make a complete UML picture, which is known as diagram. So it is very important to understand the different diagrams to implement the knowledge in real life systems. We have two broad categories of diagrams and they are further divided into subcategories: structural diagram and behavioral diagram. Structural diagram represent the static aspects of a system. These static aspects represent those parts of a diagram which forms the main structure and is therefore stable. These static parts are represented by classes, interfaces, objects, components, and nodes. Structural diagrams can be subdivided as follows. Class diagram. Class diagram represents the object orientation of a system, shows how classes are statically related. Object diagram represents a set of objects and their relationship at runtime and also represent the static view of the system. Component diagram. Component diagram describes all the components, their interrelationship, interaction, and interface of the system. Deployment diagram are a set of nodes and their relationships. These nodes are physical entities where the components are deployed. Package diagram describe the package structure and organization, covers classes in the package and packages within another package. Composite structure or composite diagram describe inner structure of component including all classes, interfaces of the component, etc. What is behavioral diagrams? Behavioral diagrams basically capture the dynamic aspect of a system. Dynamic aspects are basically the changing, moving parts of a system. UML has the following types of behavioral diagrams. Use case diagram describe the relationship among the functionalities and their internal external controllers. These controllers are known as actors. Sequence diagram visualize the sequence of calls in a system to perform a specific functionality. Communication diagram. Some communication diagram, same as sequence diagram, except that it focuses on the object's role. Each communication is associated with a sequence order number plus the past messages. State chart or state machine diagram represent the event-driven state change of a system. It basically describes the state change of a class, interface, etc., used to visualize the reaction of a system by internal external factors. Activity diagram. Activity diagram describe the flow of control in a system. It consists of activities and links. The flow can be sequential, concurrent, or balanced. Interaction diagram. Interaction diagram combines activity and sequence diagram to provide a control flow overview of a system and business process. Time sequence diagram describe the changes by messages in state, condition, and events.